Hello and welcome to GM-BIST construction. I remain Benedict. Today we are going to learn how to design our slanted or inclined columns. And so we have a design here which I've actually carried out the modeling of the slanted column, but I would like to show you how to carry out the process involved in designing your slanted columns. And so we just have to check this in our using our architectural design. So what are slanted columns? Slanted columns are vertical load carrying members that are intentionally tilted at an angle to form the vertical axis, or from the vertical axis. They're intentionally tilted at an angle from the vertical axis. So you can see this is an angle formed here, there's an angle formed here, there's also an angle formed here. So that can be based on maybe your structural analysis, sometimes if there's need for a support, or maybe from the architectural design. So you can actually find your slanted column or inclined columns in unique architectural designs, stadium structures, bridges, pedestrians, walkways, building where extra space is needed at the ground floor. Like here you see a space here, maybe if you want to put a straight column here to occupy space here. So at the ground floor, you can be at the lower floors, you can be at the first floor, the second floor, the third floor, as the case may be. So unlike normal columns that carry mainly axial load, slanted columns, please you take note of this, slanted column behaves like beam columns. This means that axial forces, bending moment, shear forces, and an additional horizontal thrust created by the angle of inclination. So once there is an angle of inclination at this point and this point, you see, because part of this side is going to be the weight or the load at this side is going to be applied by the column here. So it acts as beam columns. So you should take note of that. You have to take note of that because your reinforcement and the size of your column. So for a vertical component, if you want to design for a vertical component, you can say V equals to V, which is the vertical component, equals to P multiplied by cos theta. And for the horizontal, the P there is your load or your force that is going to be applied by the beam on the angle formed. And if you have the horizontal component, which is B multiplied by sin theta, and force, which LP is the force or the load. So I don't want us to do much about this. The next thing we do is to go to the practical aspects. So you can see how the column is being inclined. So this is what I'm going to do. I'm going to delete this column. So let me insert it here. So you can see that now it's straight. It's like a straight column. It's not inclined at any angle. So the next thing I will do is just click on this property. So somebody would like to ask, why am I using this size of column? Just like I said, from the literature analysis that I've done, it shows that a 230 by 230 column cannot work, a 450 by 230 column cannot work, because this is actually serving as a beam column. So the load that is going to be applied on it. So but that does not mean that once you have an inclined column, you begin to use this side. You can try from the smaller size, and as it keeps increasing, you'll be running your analysis, be doing your checks. So I don't want us to waste much time. I just want to show you how that can be done. And so this is the position at which the column is going to be inclined to this place. So what I will do is I will just click on this, then I'll go to properties and click on both insertion points. I'll just click on it, then I'll come here and I click. The next thing I'll do is just to say update and see how your column has moved. So let me reduce this size so that you'll be able to see it. So this is just the logic. So at every point where you need your column intersection, you can actually do that. So you can see the way the column is being aligned. So the next thing I will do is to run my analysis, which you know how to run your analysis. If I run my analysis and I discover that this phase, I can increase the size of this column. So thank you. If there are questions, you can actually pen them down through our comment section. Always do well to like, subscribe to our YouTube channel. I remain Benedict from GM-BIST Construction. Thank you.